Assalamu alaikum ji. We'll discuss May June 2020 paper 3.3, first part of it. As you already know, there are two different types of questions in our P3 or practical exam papers. One is a wet experiment and other is a microscopic. So today we are going to discuss a wet experiment from summer 2020. Look at this first question. Before you proceed, read carefully through whole of question 1. Plan the use of 2 hours to make sure that you finish the whole of the question 1 and question 2. We are going to discuss question number 1 first, so it will take around 1 hour. You will have to read it carefully throughout this first question before you actually start this experiment. And if anything like the water bath has to be started, or water bath has to be prepared, or some other thing has to be prepared and set aside for some time, so that's important to manage your time. So let's see question number 1. Energy drinks contain a high concentration of carbohydrate such as glucose as a source of energy. Glucose is a monosaccharide which can be quickly metabolized by body cells, releasing energy during exercise. Glucose changes the color of potassium magnate solution P from purple to colorless. So this should be your end point. Okay, so potassium magnate solution, which is P, it changes color from purple to colorless. So this is your end point. Okay, you will need to prepare different concentration. This is what you are expected to perform in this experiment. Prepare different concentrations of glucose solutions. Record the time taken to reach the end point. You have to record the time taken to reach the end point for the known glucose concentrations. Use your results to estimate the concentration of glucose in an energy drink U. So there are two things that you have to do. You have to record time taken for each glucose concentration to reach the end point, and then you are given a solution U with an unknown concentration, and you have to estimate the concentration of U. So let's see the first part. You are provided with the materials shown in table, like G. You can see this is G. This is W. This is A. This is P. And you have U. Other than that, you have 6 test tubes provided, you have 5 empty beakers provided, and you have a permanent glass marker, and you have few syringes and a stopwatch provided. Before you start your experiment, you should see whether you are familiar with this stopwatch. You can start this and you can stop, and you can record the time taken, the time from this stopwatch. Okay. It is recommended that you wear suitable eye protection. If A or P come into contact with your skin, wash off immediately under cold water. You should take measures to protect yourself first. Safety first. You will need to prepare different concentrations of glucose solution. The lowest concentration you will prepare is 12%. you will need to prepare 10 cm cube of each concentration. So this is the total volume that you have to prepare, 10 cm cube of each concentration. The table 1.2 shows how to make up two of the concentrations of glucose solution you will use. Decide with other concentrations of glucose solution you will use. Complete table 1.2 to show how you will prepare the concentrations of glucose you will use. In the first column you have percentage of glucose, and in second column you have to use the volume of G, and in the third column you have volume of W that has to be added into it. The total volume to be prepared is given in this question here. This is the total volume that you have to make, total volume, and this is V2. This concentration, percentage of glucose concentration which is given, you can see in the materials provided. This G provided has 20% glucose concentrations. So using this 20% glucose concentration, you have to prepare other concentrations. At least there must be 5 concentrations that you have to prepare, and they should be from 20% to 12%. Okay. The concentration that you decide should have equal intervals, 20, then lower than 20, then the next lower than that, and the next, and the next. So 1, 2, 3, 4, 5, and 6. It makes 6, or maybe it's at least 5 concentrations. Okay. So how you can divide these concentrations from 12 to 20 in such a way that there are equal intervals in between. So you can take with an interval of 2. So if it is 18%, then 16%, and then 14%, and then 12%. So there is total concentration that you prepare have to be at least 5 concentrations. So this makes 5 concentrations. 20%, 1, then 18%, 16%, 14%, and 12%. So you see there is an equal interval of 2 in between. Number 1, equal intervals, and number 2, the maximum and the minimum value have been included in it. Maximum and minimum value included in it. Now we have to calculate the volume of G and volume of W that has to be added into it. So we apply a formula. C1 V1 is equal to C2 V2. C1 in this case is 20% volume we have to calculate. C2 is the concentration that we have to prepare in this case. So for instance, the first concentration that we are going to prepare is 18%, so I will write 18 here. And then total volume that has to be prepared is V2, that we will take from here, from the question, that is 10 cm cube. So V1 would be equal to 18 into 10 divided by 20, so that makes, we can calculate it, and that would be 10 2s are 20 and 2 9s are 18. Okay, so V1 is 9 cm cube. So I'll write 9 cm cube here, and to make total volume 10, 1 cm cube of this distilled water will be needed. Similarly, to prepare the other concentration, which is 16%, so what we will have to do is put this 16% in place of C2. So that would be, the rest of the other values would stay the same, like 20 into V1 is equal to 16 has to be prepared, and total volume to be prepared is 10. So V1 will be 16 into 10 over 20. So this would make 10 2s are 20 and 2 8s are 16. So V1 will be 8 in this case. So 8 cm cube V1 and 2 cm cube of water added into it to make total volume of 10. And the next, to prepare 14%, let's see, to prepare 14%, we will put this 14 in, instead of this 16 here. So that would give us 20 into V1 is equal to 14 into 10. So that would give us V1 is equal to 14 into 10 over 20. So that would give us 7. So 7 cm cube of this volume of G, and 3 cm cube of distilled water has to be added into it. And for the next concentration, which is 12, 6 cm cube of volume of G and 4 cm cube of distilled water has to be added into it. So this is for 2 marks. What you have to notice when you are filling or completing this table, number 1, no units should be written in the columns. Okay, like you should not write a cm cube here, or you should not write the units in these columns, like cm cube here or cm cube here. If you write cm cube here, you will lose 1 mark here. So don't write these values here. Okay. Now, the other thing that you need to consider is, the concentrations. Minimum 5 concentrations to be made with an equal interval. Okay, including the range given. So these are the 2 things that you need to consider while you are filling this table. The next part, carry out step 1 to step 8. Before you start your experiment, you should read these steps first, and then you should accordingly plan the procedure that you have to follow. And while doing this, you should keep on ticking, prepare the concentrations of glucose solution as shown in table 1.2 in the beakers provided. Okay, the first thing that you have to do is label tubes with the concentrations of glucose prepared in step 1. So this is step number 1, and you should take it and see what you have to do is, you have been provided these test tubes, so you should label these test tubes with the concentrations that have been mentioned in the table, like 20%, okay, 20%, and you should put it back into the rack. The other one then is 18%, okay, put it back again. The other one is 16%, okay, then 14%, and 12%. Okay, so these are the test tubes labeled with the concentration that have to be prepared. Put the cap back and place the permanent marker back. Okay, now this is the first step in this procedure that you have already marked tick in this case. This third point is put 1 cm cube of 20% glucose solution into the approximately labeled test tube. So second point, with this syringe, take 1 cm cube of 20% glucose. 20% glucose is G, so you have to take 1 cm cube. Try taking the syringe that has less least error, or the smaller syringe to measure 1 cm cube. Okay, So I'm taking this smaller syringe to measure 1 cm cube. So the volume has to be filled to this point, and this end of this rubber part with the plunger, that should be adjusted to this point to fill 1 cm cube. So I'll take that fluid here. Okay. So you see this is 1 cm cube, and this has to be put into the test tube, which has labeled 20%. So 1 cm cube is put into it. Try it doesn't come in contact with the walls of this test tube. Okay. Put this syringe back, maybe in the same beaker from where you have taken, so that it doesn't mix up with the other fluid. So put it back into the G, and this test tube back into the rack. Okay. The next point is repeat step 3 with each of the other concentrations of glucose. So I'll put tick here. Okay. And I'll take the other volumes, repeat step 3 with each of the other concentrations of glucose. So there are other concentrations that have been prepared accordingly. So you will from these beakers. So it is an 18%. Okay. So this is an 18% solution that should have been made earlier. I'll take 1 cm cube from here, and we'll put into the next test tube that has been labeled 18, then from the 16 into 16, and then from 14 into 14, and from 12 into the test tube that has been labeled 12. So let me finish that, and then we proceed with the other step. So to prepare 18%, I'll take 9 cm cube of G into a beaker labeled 18%, and I'll put 1 cm cube of distilled water into it. Okay. So I'll put 1 cm cube of water into it. And so you see, this is 18% glucose solution that has been prepared by putting 9 cm cube of this G solution into it, and 1 cm cube of distilled water. To prepare the next concentration, which is 16%, I have to take 8 cm cube of this G. This is 8 cm cube of G taken with this syringe into this beaker, and 2 cm cube of distilled water that has to be added into it. So to measure this 2 cm cube with this syringe, and is then added into this beaker. Okay. Mix it so that this is thoroughly, glucose is thoroughly dissolved in the whole volume. Okay. Similarly, to prepare 14%, the next volume, which is 7 cm cube of G and 3 cm cube of distilled water has to be added into it. So let's see, 7 cm cube from here, this is 7 cm cube, and then 3 cm cube of this distilled water. It has to be added into it. Okay, and finally the 12 cm cube. Okay, 12% 12% glucose solution has to be prepared by adding 6 cm cube of G, 6 cm cube of G, and 4 cm cube of distilled water. These syringes should not be mixed together. Okay, the one that is being used for the water is only used for water, and the other, which is used for G, is kept in that beaker so they don't mix up and they are not contaminated with the unwanted solutions. Okay, and they don't change the concentration. So I have prepared these concentrations. Now, following these instructions, according to this repeat step number 3 with each of the other concentrations of glucose. Put 1 cm cube of A into each of. So before that, take 1 cm cube with this syringe. Okay, 20%, 1 cm cube of 20% has already been put into this test tube, and now 1 cm cube of 18%, 1 cm cube of 18% has to be. So this is 1 cm cube. It has to be put into the test tube labeled 18%. Okay, and then you can rinse this syringe before using or before taking the other solution. And then I have another syringe here, so I can use the other syringe, or you can rinse with the water. For washing, you may be given a beaker labeled for washing. So take 1 cm cube from here, from this beaker labeled 16%, and put into a test tube which has been labeled 16%. Okay, and then from the beaker labeled 14%, take 1 cm cube from here. Okay, and put it into the test tube labeled 14%, and then finally 1 cm cube of 12% into the test tube labeled 12%. Okay, so this step has been completed. The next step is put 1 cm cube of A into each of the test tubes and shake well. So this is the next step. Take 1 cm cube of A, this beaker. This beaker has been labeled A, so it has a solution in it. I'll take this syringe which has been used for distilled water, and I'll use this to take 5 cm cube. This syringe measures 5 cm cube, and I will put 1 cm cube in each test tube. Okay, so this is 1 cm cube put into this, 1 cm cube into this, 1 cm cube into the other, 1 cm cube into this, and 1 cm cube into the last. Okay, and then following the instructions, you have to shake these test tubes so that these solutions are mixed. Okay, so it is 20%, then 18%, 16%, 14%, and 12%. The next step is shake gently to mix. The reaction will start as soon as you put P into the test tube. Step 6. Do not stop the timer. Keep it running continuously. Put 1 cm cube of P into each of the test tubes and start timing. Shake gently to mix. So I have this timer. Similarly, 1 cm cube of P has to be added into each. There are two ways we can put this 1 cm cube of P one by one, and we can record time for each, or we can record time for all of them at the same time. And for that, you see, we have measure the time taken for each test tube to reach the endpoint. As each endpoint is reached, record the time taken in the space provided for raw results. Do not stop the timer. Record in A2 the time taken for each test tube to reach the endpoint. If the endpoint has not been reached after 600 seconds or 10 minutes, record the time as more than 600. So what we'll do is, I have these test tubes. Okay. So 1 cm cube of P has to be added into it. So I will take 5 cm cube of this P in this syringe, and I will start the timer. Okay. You can for each test tube you can record the start time. Okay. So this is 0 start time, and I put just 1 cm cube into it. Okay. So this has been started like this. Okay. Then I can record time, start time for the next one. Okay. Or I can just quickly put 1 cm cube into each. Okay. So there is less delay, and then start, shaking them gently. Okay. And observe the changes in the color, and record the endpoint taken in, endpoint reached in each test tube. So keep it gently moving. Okay. This white paper is used to see, that makes the color change clearly visible. We have to wait till 10 minutes. If even after 10 minutes the color change has not occurred, so you see this has gone lighter, and okay. So this is colorless endpoint reached in 1 minute and 44 seconds, and it is in 12 minutes. This is in 14, this 18, and then this has the time in 20 has reached even earlier than that. We just missed this. So this is the big the trouble in this experiment, that you may not accurately notice when the endpoint reached in each of the test tubes. So for such experiments you should write the raw data, for example 20%, then 18%, 16%, 14%, and 12%. Start time, if it was the start time that was if different for each, then you can write start time here and then end time here. So this would make it easier to record the time. Otherwise what will happen, it will become difficult to record the end time. It would so quickly reach that you will miss out the end time. However, in this case the end point has not been correctly recorded. You should make these raw table to record the start time and then the end time carefully so that you don't miss the end point. We can repeat it. I'm not going to repeat it now, but let's see the next part then. So this is use this space for the new result. So before actually you carry out this step number 6, you should have make some preparations here, as I said earlier, that 20%, 18% percentage concentration should be written here, 16%, 14%, 12%, and you should write start time and end time. Okay, so this is how you should have, there are no marks for this raw data. However, whatever your start time is and end time is, you can repeat this experiment and you should record them. When you're recording these values, the time taken to reach the end point, then you have to make a difference from the start time and end time and write in maybe the seconds. So this would be the time taken to reach the end point. Okay, so you can calculate it. That should be written in seconds, and that should be in whole seconds, no seconds in decimals. Okay, record in whole seconds. Okay, then it comes drawing or recording your results in the appropriate table. This is for 5 marks, and this is very important part of this paper, where you have to actually use your understanding or learning to draw a table scientifically correctly. The first column that we should make is the independent variable. In this case, an independent variable is the concentration of glucose. Okay, we should put a backslash and write percentage concentration. Okay, we can, so this is percentage concentration, and then the time taken to reach the end point. Time taken to reach end point. Okay, and we can simply write time taken, or we can simply write time. Okay, so that doesn't matter, and that is in seconds, so we should put this unit here, second and whole second. Okay, so whatever the time is recorded, that should be in whole seconds. So it is 20%, it is 18%, it is 16%, 14%, and 12%. No unit with these values in the column should have been written. Okay, you should write the percentage here in the heading and the unit here in the heading. This is an independent variable, that should be the first column. This is dependent variable, that should be the second column. And no unit should be written with these volumes or these concentrations, in the first column. So if you write percentage here, you will lose 1 mark. So no concentrations or no units in the column. Similarly, if the time has to be recorded in this case, it may be 40 seconds taken in 20%. I just assume you can accurately record that time. As the concentration decreases, the time taken will increase. So it may be 59 seconds, it may be 63 seconds, it may be maybe 95 seconds, it may be 130 seconds. So whatever the time that you record, you should write that here in this column. Okay, but that should be in whole number. Don't write that in decimal points. So that's not the correct way of writing the time in, or recording the time in seconds. Label a test tube U and put 1 cm cube of U into this test tube. Repeat step 5 to 7. What are step 5 to 7? You have to put 1 cm cube of A and 1 cm cube of B and record time taken for the U solution as well. So whatever the time that you take for U, you should write it here. For example, it is maybe 45 seconds, okay? And estimate the concentration of glucose in U. What you have to do is compare this time taken 45 seconds with the time taken in this column. It is closer to this 40. So what we will estimate is that the concentration is closer to 20%. The unit has already been written, so I'll write 20% or maybe more than 20% as less than 20%. The time taken is more than 40 seconds, so the concentration should be less than 20%, but between 20 and 18%. Describe how you would modify this procedure to give a more accurate estimate of U. You see, it is difficult to estimate whether this is 20% or it is 18 point something or 19 point something, okay? So this concentration of U is between somewhere here from 20% to 18%. What I should do is take a narrower concentrations from 20% to 18%, okay? Take narrower range of concentrations from 20% to 18%. So this is one thing that needs to be done. Secondly, we can repeat the experiment 3 times and calculate the mean. It will improve the reliability. That would obviously improve the accuracy. And then we can use calorimeter to judge the endpoint. Okay, so there are different ways we can improve the accuracy. We can improve the independent variable, we can improve the dependent variable, and we can also consider controlling some variable that we can also mention in this case. State 2 significant sources of error when carrying out step 7. Step 7 was here we can see this is step 7. Measure the time taken for each test tube to reach the end point. Okay, so there are 2 things. One is the time taken being recorded to reach the end point, and end point is the color change. So there may be difficulty in judging the end point, and there may be difficulty in starting and stopping, or due to reaction time error of the human, there may be difficulty in recording the time precisely, or there may be delay in when the solution P has to be added into each of the test tubes. So sources of error would be difficulty in judging endpoint. Okay, and secondly, human reaction time error or difficulty in recording time due to human reaction time error. Okay, or due to the human reaction time. Now describe how you would modify this procedure to reduce one source of error as stated in this. So there are 2 sources of error that you have stated, and one of them can be this experiment can be modified to improve one of the sources of error. That may be use calorimeter. Okay, that would improve this one source of error, and to improve the other source of error you can use slow motion camera, or multiple observers can be asked to record the results, so that this second type of error can be reduced. Okay, An investigation was carried out into the effect of drinking an energy drink on blood glucose concentration over a period of 3 hours. The results are shown in table 1.3. This is an independent variable that should come on x-axis, and this is dependent variable that should come on y-axis. Okay, so the first thing that you should do is decide suitable scale, and the maximum area of the graph should have been covered in this case. Okay, so let's see, from 0 to 3 there are 1, 2, 3, 4, 5 and 6 boxes. So it is from 0 to 3, 0.5. So if I take 2 boxes equal to 0.5, so this is 0, this is 0.5, and this is 1. No, this doesn't work. It doesn't fit in the whole value. So if I take 1 box equal to 0.5, so that would be 0.5. This would be 1, and then 1.5, and then 2, and then 2.5, and then 3. Yes, this is absolutely okay. And with that, you have to write unit here. That's very important. Time and backslash hour. Similarly, you can decide these values. They range from 5.2 to 7.9. Similarly, you should work on the y-axis. Label this glucose concentration. Okay, and it is 5.2 to 7.9. So if I start with 5 here, okay, and I end it to maybe 8 or 9 here, so this may be 5, 6, 7, 8 or 9. That's fine. 5, 6, 7, 8 and 9. That's more than 3 over 4th of this graph used in this way. This glucose concentration is in millimole per dm cube, so you should label it completely, millimole per dm cube. Okay, then the next point is against 0.0, it should be 5.2. so pick up a value from here, and you should put a dot here. It should be 5.2. Okay, so this is 5.2. Then against 0.5, it is 7.5. So it is 7, and one value is so that is somewhere here. Okay, and then at 1 hour it is 9.1. so 1 hour 9.1, that should be here. At 1.5, there is no value at 1.5. There is value at 2, which is 8.4. 2 by 8.4, so that should be 1, 2, 3 and 4 here. And 2.5, there is no value. At 3, it is 7.9. so 7.9 should be here. Okay, so I have put these values here. Now what you have to do is you can make a ruled line. You should circle these. Okay, and then with the help of a ruler, or you can join these line with free hand, so that's fine both the ways. So I'll join these lines. Okay, so this is how you should make this graph. For making this graph, the points are awarded for writing a suitable scale, for labeled axis, for axis correctly oriented, and for the plotting points. And there should not be any extrapolations in this case. No extrapolations. What are extrapolations? We'll discuss in some other lesson. So that's it for today. Thank you very much. Allah Hafiz.